Hello, Do4911 here, and today we're going to start learning about the Boeing 777 as made by PMDG Simulations. This is a very accurate and faithful simulation of the real Boeing 777, which, at the time of recording, is the most popular wide-body aircraft with the highest number of orders across all of its variants. Now, a couple of disclaimers that I need to get out of the way before we begin. Number one, I am not a commercial pilot. This video and the ones that follow will be based on my own understanding and study of the documentation that PMDG provides with this aircraft. Therefore, I may make some mistakes, and I may do things differently to real-world pilots. Please understand that I am simply a flight simulation enthusiast sharing my passion with the world. Number 2. This is a simulation of a complex aircraft. Therefore, these videos will not be suitable for a complete beginner to flight simulation. These videos have been made with the assumption that the viewer is comfortable with elements which are common in passenger aircraft like this one. These elements will be things such as the ability to read and understand a primary flight display, an understanding of what an airport's departure and arrival procedure is and how they relate to one another. In the past few years on YouTube, I have created a playlist of videos aimed at complete beginners to flight simulation. Each video in that playlist will give you the knowledge and understanding required to fly an aircraft like this one. Now, while I will do my best to explain this aircraft in as much detail as possible, there will be some things that I will skip over or only explain briefly. Okay, so with that out of the way, let's crack on and begin learning about the Boeing 777. To view the overhead panels easily, simply right-click anywhere to bring up the menu, and then go to Cockpit and select Upper Overhead Panel. Now, if I zoom out a little here, you will be able to see that the overhead panel area is actually quite large. This area is divided into 3 distinct sections. First, near the back of the flight deck is the Maintenance Overhead Panel. This area contains a selection of switches which are mainly used by engineers when performing maintenance activities in an aircraft while it's on the ground. You will probably never be required to use any switches here during a flight, therefore I'm not going to explain what anything does on this panel. Next, if we move forward along the overhead panel, we come to some overhead circuit breaker panels. If I zoom in, you can see that the circuit breakers are not modelled in this aircraft. Once again, I'm not going to explain what goes on here because you will not be required to look at this panel during a flight. The third section closest to the pilots is the main overhead panel, and this is where we're going to spend the rest of the video. To get a better view, right click to bring up the menu, go to Cockpit and then select Overhead Lower Panel. So I'm just going to get the panel centered up on the screen here. To move the view like this, I'm simply holding down the spacebar and moving the mouse. To adjust the zoom, you just need to roll the mouse wheel while holding down the spacebar. As you can see, there are a lot of buttons and switches on here, but don't worry, we're going to take a look at every single one and explain what it does and why it exists. Now, I should mention that the panel that we're looking at here is for a passenger variant of the 777. If you choose to fly one of the cargo variants, you may see some slightly different switches in certain areas. So we're going to take a look at the panel by starting in the top left and working our way down like this. Once we reach the bottom, we're going to move across to the next column and move down, and so on until we reach the end. This is called a flow, and this is the way that we're going to check the overhead panel in a future video when we're preparing for a flight. So let's get started. The first switch we have is the ADIRU switch. This turns on the Air Data Inertial Reference Unit. This is part of a system which is made of various gyroscopes, accelerometers, pitot probes, static ports and temperature probes. This system provides air data to the aircraft so that the aircraft knows its speed, altitude and attitude and angle of attack amongst other things. This basically helps the plane know where it is and which direction it's pointing in three-dimensional space. The black rectangle beside it is an on battery light, which comes on when the ADIRU is operating on battery power only. Now, on a side note, I want to talk about the switch itself briefly, because there's many like it in this plane. Now, this is a simple toggle switch. Press it in to turn the system on, press it again to turn the system off. However, you'll notice that the switch is split into two halves, a top half and a bottom half. The top half indicates the status of the switch, whether it's on or not. The text in this section will always be white, and when the text is visible, the switch is on. The bottom half will indicate if there's an issue with the system associated with the switch. For example, right now the ADIRU switch is indicating that the system is off. Now if we press the switch, the top portion is now telling us that the switch is on and the off light has disappeared. Generally speaking, if you look at the overhead panel and see a yellow light, that indicates a problem. Now in this video, the aircraft is sat on the ground with the engine switched off, so there will be lots of warning lights, which is normal and it's to be expected when the engines are switched off. Anyway, let's continue. The next section has a couple of switches relating to the flight control system. The first switch is the thrust asymmetry compensation switch. Now if this system detects that one engine is producing more thrust than the other, then it will automatically move the rudder to offset the yaw force of the engines, making it easier to fly the plane in the event of an engine issue or an engine failure. The next switch is the primary flight computer's disconnect switch. The 777 uses a fly-by-wire control system. This means that when a pilot makes control inputs, this does not directly move the flight control surfaces on the aircraft. The pilot's inputs are sent to a primary flight computer. The primary flight computer then interprets the pilot's inputs and sends a signal to an actuator control electronics unit. This control unit then controls the movement of the actuators or the pistons attached to the control surfaces to actually move the surfaces such as the elevator, the ailerons or the rudder. Now this switch is hidden underneath a guard. The guard on this switch will automatically move the switch to its correct location when it's pushed down. For example, if I open the guard by left clicking on it, then left click the switch to move it into the disconnected position. If I click the guards to close it, it will automatically move the switch back to the auto position, which you can see here when I open the guard again. Moving down to the next panel, we have a lot of controls related to the electrical system. So the first switch is the main battery switch, which will supply power to the most essential systems for a limited time. On the left we have the switch for the IFE, which is the in-flight entertainment systems, and also the passenger seats. So when this switch is on, the systems are active and the plug sockets next to the passenger seats are powered. Next to that is the cabin and utility power switch. This supplies power to areas such as the main cabin lights and also the crew galleys where they store and prepare food and drinks. On the right is the selector switch for the APU. This can be used to turn the APU on and off. The APU, or Auxiliary Power Unit, is a small jet engine which sits in the tail of the 777. When it is running, it will supply the plane with electrical power and high pressure air, which is used to provide air conditioning inside the aircraft, and it's also used to start the main engines. Below the selector is a fault light, which will indicate if there's a problem with the APU. Below the battery switch is the APU generator switch. When this switch is enabled, this will connect the electrical generator in the APU to the rest of the electrical system inside the plane. Below that you have the left and right electrical bus tie switches. Now, an electrical bus tie will allow the left and the right side of the electrical system to connect. The main benefit of this is it provides redundancy or a backup in the event of an electrical failure. If one side of the electrical system experiences a failure, the power can then be routed through these bus ties to ensure that electrical power continues to be supplied to both sides of the aircraft. Now all of this is done automatically in the 777, provided that these bus tie switches are enabled. The next couple of switches are for external power sources. At a lot of airports, you will see a ground power unit plugged into an aircraft. Now this is typically a generator which supplies electrical power to a plane. Now this saves the aircraft from using all of its power from the battery, and also allows the plane to have electrical power when the APU is not running. On the Boeing, there are two locations where ground power can be connected. These switches allow you to enable the connection between the ground power unit and the electrical systems within the plane. Next up, we have the left and right generator control switches. These generators are located within each engine, and these are the main supply of electrical power when the engines are running. As the engines spin, they turn the generator built into the engine, which then provides electrical power to the aircraft. Below each switch is a drive disconnect switch, which is covered by a clear guard. Now, in some situations, there may be a problem with the engine, and you may need to disconnect the generator within the engine. This switch allows you to physically separate the generator from the components which make it turn. It's kind of like disengaging a clutch, which allows a car's engine to transfer power from the engine to the gearbox. Now this is a last resort action, because once an engine generator is disconnected, you cannot reconnect it without engineering and maintenance actions on the engine. Lastly, in the middle we have two backup generator switches for both engines. Again, these provide redundancy if there's an issue with the main generator within an engine. And finally, at the bottom of this column we have the left windscreen wiper selector, which allows you to set the wiper to different speeds. Starting on the next column, first we have the RAS runway override switch. RAS is the Runway Awareness and Advisory System, which provides pilots with automated alerts about which runways they are operating near. You might have heard a RAS alert say something like this.
On runway 27, right.
This switch allows you to turn this system off, which you may need to do in the event of a problem with the aircraft. Moving down, the first switch we have is the emergency lighting system. When the guard is closed, that moves the switch to the armed position, so that the emergency lights will automatically turn on when needed. Next is the service interphone switch, which allows pilots to speak with ground crews who have a headset plugged into the plane. You probably won't end up using the switch in your simulator though. The switch on the right is another clear guarded switch for the passenger oxygen system. In the event of a cabin depressurization, the oxygen masks above passengers' heads will automatically deploy. This switch here allows pilots to manually deploy the masks, which is why it's guarded. Like the engine generators, once you push this switch, you can't reverse the action without maintenance engineers checking and repacking the oxygen masks into their overhead containers. The row of switches along the bottom here is for the cockpit window heaters. This helps to prevent the cockpit windows from icing or fogging up. On the next panel, the first switch is for the ram air turbine. This is a miniature windmill which can be deployed as a last resort if there is an electrical or hydraulic failure with the aircraft. This switch deploys the ram air turbine, which catches air and spins. This is another action which cannot be reversed after it's deployed. The ram air turbine remains deployed until a maintenance engineer can check and stow it. Underneath that you have 8 switches which all relate to the hydraulic system within the aircraft. These switches all represent various hydraulic pumps which are used to move hydraulic fluid through the aircraft. The hydraulics ultimately move the flight control services such as the ailerons, the elevator and the rudder, and they also move other components such as the landing gear. The hydraulic system is separated into 4 sections: the left, the center number 1, center number 2, and the right system. The top row of switches represent the primary pumps. These will run throughout the entire duration of a flight. The left and right primary switches are pumps powered by the left and right engines. The center 1 and center 2 switches enable electrically driven pumps. The selectors underneath represent 4 demand hydraulic pumps. These act as backup pumps, but they also operate automatically during periods of high system demand, such as during the takeoff and the landing. The left and right demand pumps are electrically driven, and the center 1 and center 2 are air-driven pumps. Below the demand pumps there are also 4 fault lights to indicate whether there's an issue with a particular system. On the next panel you will find the selectors for the no smoking signs and also the seatbelt signs. Beside those is one of the microphones that will pick up any and all noises within the cockpit for the cockpit voice recorder. The panel at the bottom of this column contains various switches for the interior lights and also the landing lights. The first selector here are brightness controls for the overhead and circuit breaker panels. With these controls you can select how bright the integrated lights are in the panel, and these light up the text and the outlines for various buttons. Next to that is the dome light selector. This controls a main light in the top of the cockpit which illuminates the whole area. The switch beside that is a storm light. This turns on the dome light overhead, but also the glare shield panel light and the forward panel lights and the center pedestal lights. Now this switch is used if pilots are flying close to a storm at night. Flashes of lightning can be very bright and distracting, and it can mess with a pilot's natural night vision in a dark cockpit. By turning on the storm light, it lights up the key areas of the cockpit and reduces the intensity of any flashes outside. On the right is a master brightness control. The outer control changes the brightness of the integrated lights in all of the panels within the flight deck. The central control is an on-off switch to turn the master brightness on or off. This overrides the individual brightness settings for each panel. The last interior lights control here is for the glare shield, which is the panel which runs along the top of the forward displays and panels. The outer control changes the brightness of the embedded lights to make the text brighter or dimmer. The smaller control is for the floodlight, which illuminates the whole panel with an external light. The last 3 switches are for the landing lights. The left and right landing lights can be found on the front edge of each wing near the fuselage, the body of the plane. The nose landing light is a light on the front landing gear structure. Moving across and up to the top of the next column, the first panel we have is the APU and cargo fire panel. On the left we have the APU fire extinguisher handle. If a fire is detected in the APU, you can pull this handle, which will activate the fire extinguisher in the APU. Above the handle is a small indicator light, which shows when the extinguisher has been used. Just beside that is a test button to test the fire detection and alarm system. On the right are 2 switches. These will indicate if a fire has been detected in either the forward or aft cargo sections of the aircraft. You can then press the switch to arm the fire extinguisher for that particular cargo area. The last switch is the discharge switch. This allows you to activate the fire extinguisher for the armed cargo section. Moving down, the next panel has a couple of engine control switches. First are the electronic engine control switches for the left and right engines. This system has full control over each engine and uses the thrust lever position to determine engine performance. Below those switches are the engine start selectors, which are used to start the engines. More specifically, setting these to the start position will open up a bleed air valve to allow bleed air from the APU to enter the engine. Now you still need to enable fuel flow into the engine as well for it to reach its idle speed, and this is controlled by a different switch which you'll see in a future video. The last switch here is the auto start switch, which arms the auto start system. Typically, starting a jet engine is a two-step process. First, you need to begin rotating the core of the engine, and you use high pressure air to get it spinning. Once it reaches a certain speed, you then need to introduce a fuel-air mixture into the core of the engine, and by igniting this produces thrust. Now when this process begins, the engine gains rotational speed until it reaches its idle speed. In older aircraft, you would manually wait for the bleed air to rotate the engine to a particular speed before you would introduce the fuel. Now for anyone who's flown a Boeing 737, you know exactly what I mean. In the Boeing 777, the auto start system automatically monitors the engine speed and will automatically introduce fuel to the engine at their correct time. The next panel has many switches relating to the fuel system. The first set of controls are the fuel jettison controls, which allow the pilots to dump fuel out of nozzles at the rear edge of each wing. This is typically done when the aircraft needs to reduce its weight to perform a safe landing. The fastest way to do this is to dump excess fuel into the air where it will evaporate. On the left and right are the fuel nozzle valve switches. These open and close the valves, which allows fuel to exit the nozzle at the back of each wing. The fuel to remain selector allows pilots to control how much fuel they want remaining in the fuel tanks after a fuel dump has been completed. Now the aircraft will automatically calculate how much fuel needs to be left to perform a maximum weight landing, but pilots can use this control if they want to select an amount themselves. The amount is displayed on one of the forward panels, which you'll see in a future video. The final switch is the fuel jettison arm switch. This arms the fuel jettison system and prepares it for dumping fuel. Below that you have the fuel pump and crossfeed selector switches. The Boeing 777 has three main fuel tanks, one in the left wing, one in the right wing, and one in the centre between both wings. Some 777 aircraft may also have an auxiliary fuel tank which sits behind the centre tank. The left and right fuel tanks have two fuel pumps, one forward, one aft. The centre fuel tank also has two fuel pumps, on the left and the right. Both wing tanks are also connected by crossfeed valves. This allows fuel to pass from one wing tank to the other to keep the fuel balanced between each wing. There are two crossfeed valves, again one forward, one aft. When using the switch, the line indicates that the valve is open and that fuel can pass from one side to the other. When there's no line, the valve is closed and each side is operating separately. The next panel contains anti-ice controls. The first selector is the wing anti-ice selector, which takes hot air from each engine and feeds it into the leading edge of each wing to prevent icing. Then you have two engine anti-ice selectors, which redirect hot air from each engine and feeds it into the intake cowling at the front of each engine to prevent ice from building up on the front edges of each engine. Below that is another lighting panel, mainly for exterior lights. First you have a beacon lights switch, which controls the red beacon light above and below the plane. Next is the nav light, which turns on the red and green wingtip lights. There is also a white light pointing backwards on each wingtip and a white light pointing backwards on the tail of the aircraft. Next you have the logo light, which lights up the vertical stabilizer where most, if not all, commercial aircraft have their company logo. The lights themselves are positioned in the top of each horizontal stabilizer. The last switch is for the wing lights, which illuminate the area around each wing and each engine. This is to benefit ground crews working around the plane at night, and also pilots conducting an exterior check of the aircraft before a flight. This small switch on the right is the indicator lights switch. This is used to test and change the brightness of all of the indicator lights in the flight deck. The next couple of switches are the runway turn-off lights. These illuminate the ground ahead and to each side of the plane to assist the pilots in identifying runway turn-off areas at night. The next switch is the taxi light, which turns on a light on the nose wheel to illuminate the ground ahead of the plane. As the name suggests, this is used to help taxi the plane in dark conditions. And finally is the strobe light switch. This turns on the white flashing strobe lights when an aircraft is maneuvering on a runway, and is also used in flight to increase the aircraft's visibility. Okay, moving to the top of the fourth column now, we're on the home stretch. So this whole column is mainly dedicated to the air conditioning and pressurization systems within the plane. First we have the equipment cooling switch. This controls the operation of the cooling fans, which are cooling components such as the flight computers. Next we have the gasper switch. Now the gasper system is the ventilation which directs air out of the little ventilation nozzles above a passenger's seat. This switch allows the pilots to control the operation of that system. The next couple of switches are the recirculation fans. The recirculation system takes air from the cabin and moves it through air filters before mixing it with fresh air and introducing it back into the cabin. This helps to ensure that the cabin is getting consistent ventilation. On the left we have a flight deck temperature selector, and on the right is a passenger cabin temperature selector. The minimum temperature for both selectors is 18 degrees Celsius. When left in the middle or automatic position, the temperature is approximately 24 degrees, and when it's set to warm, the temperature is 29 degrees Celsius. In between those two selectors is an air conditioning reset button. If one of the systems here experiences an issue, this button can be used to try to reset and restart that system. Moving down, we have two pack switches. The word pack stands for Pneumatic Air Cycle Kit, and it's the system which takes fresh air from outside of the plane, conditions it, and uses it to provide ventilation and pressurization in the cabin. There are two pack systems in this plane, one on the left, one on the right. These switches allow you to turn each one on or off. In between those are two trim air switches. Trim air is hot bleed air, which is taken from the hot part of an engine. This air is mixed with fresh, conditioned air and fed into the cabin. Trim air is mainly used to help control the temperature of air entering the passenger cabin. The next panel contains controls for bleed air. Bleed air is high pressure air which is taken from various sources to power various systems. I'm actually going to start at the bottom first for this one. These two switches enable hot, high pressure bleed air to be taken from the left and right engines. This central switch allows bleed air to be taken from the APU in the tail of the aircraft. Now remember how the electrical system can redirect electrical power from the left side to the right and vice versa. Also remember that the fuel system can move fuel between the left and right tanks. Well, bleed air can also be moved from one side of the plane to the other if needed, and that's what these three switches do. These are the isolation valve switches, which control valves which allow bleed air to move from a particular engine or APU to the desired location. The next section is the pressurization panel. Like many other systems in the plane, this is typically controlled by an onboard computer. However, pilots have some manual controls here to control the aircraft's pressurization. Now, pressurization in a plane works kind of like a balloon, but instead of having one neck, it has two. Now we all know that if you keep blowing up a balloon and increasing the pressure inside, eventually it will pop. But what if we could stop it from popping by releasing that air through the second neck? This is essentially how a plane is pressurized. The packs push fresh air into the cabin for passengers to breathe. Then the air is released very carefully through outflow valves. And by controlling how much air passes through the outflow valves, you can control how much pressure is kept inside the plane. This panel allows pilots to control how the pressure inside the plane is managed. The first two switches are the outflow valve switches, which tell the plane if the outflow valves are to be controlled automatically or manually. There are two valves, a forward and an aft valve. The two switches below allow the pilots to manually open or close an outflow valve. Now the position of a valve is analog and it can be tweaked to control how much air is let out of the plane. The valves are not just open or just closed. They can be opened a little bit, opened by a quarter, by a half, 10%, you get the idea. Finally, on the right is the landing altitude selector. The landing altitude is important for the plane to automatically calculate how to control the pressure as the plane moves from its cruising altitude through its descent to landing. The landing altitude can be obtained automatically from the destination airport, which has been programmed into the flight computers, or it can be set manually by the pilots using this control. The final selector on the overhead panel is the right side wiper selector, which can be set to various wiper speeds. The last quick thing to take a look at is this Analogue Compass, which can be used for navigation in the very unlikely event that the other electronic navigation systems become unreliable. So that about covers it for the overheads panel video. Now, if you wish to study the systems behind each of these panels and switches, you can take a look at the FCOM 2 document that comes with the aircraft, and this will give you detailed information about each system within the aircraft. Hopefully now you'll have a lot more confidence at least knowing where to look for certain switches, and hopefully you've learned a little bit about some of the things that happen when you hit these buttons. In the next video, we're going to be taking a look at the glare shield, the forward panels and displays. So until the next time, thank you all very much for watching, take care out there, and I will catch you all later.